Okay, hi everyone, and well, today's orchestrator meeting. Let's see how many topics we can come up with. I'm sorry. We have those two iSCSI issues. One issue is where the container name contains a dot. So we've learned that you should not use container names with dots in it because if you Podman puts the container name into the etc host in order to make it resolvable as a DNS name. And the socket module of Python has a function get fqdn, and that if it does not find a host name with an fqdn, it scans the etc host file for aliases that contains dots, which means that if we are combining both, we have the get fqdn function returning the container name if it contains dots as an fqdn. No, super broken. And I'm either fqdn, again, I can't blame Podman. So here we are moving over to container names with dashes instead of dots. Hey Travis, welcome here.
Yes, hello.
And the second issue is that the C groups are not shared between the container and the systemd unit. That got fixed by someone contributing it, but that's already in Pacific as far as I know. So that really doesn't affect downstream except for the TCMU runner container that that escapes the C group because we are running it in the background. So that's something we have to take care of. But fortunately, we have answers to both of those issues, so we don't need to find an issue, find a solution today. So, anything else we can discuss today? I'm a bit out of topics because I really hadn't done anything else than iSCSI this week, plus downstream.
Talk about LSO.
LSO.
Yeah, to follow from a couple weeks ago, I was curious to where we are with. I saw your email. Was it yesterday? About can we use it upstream? Any concerns with that? I didn't see a reply to that. Just wondering if
Me neither.
LSO has responded. No.
Yeah, it's still a concern, right? If LSO does not have a way to install LSO in a vanilla Kubernetes environment, we, I for one have, I don't know. I don't know if I really want to make it mandatory for the Rook Manager module if upstream vanilla Kubernetes installations are not really supported by the LSO.
Yeah. I mean, so just to be clear, we aren't talking about making it mandatory. We're talking about consuming an arbitrary storage class. If it is LSO or some other storage class type that we do understand, then we'll make use of whatever other information we can extract from it. And so we'll quote unquote support LSO in that sense, but we definitely don't want to tie ourselves to a particular specific provisioner because not everyone will use the same one necessarily. That said, we probably should form an opinion about what we want to recommend, and there is no upstream installable LSO, then that's probably not the one that we want to recommend that people use, right?
Except we make it upstream.
Yeah.
But I know LSO team has said in the past that it should install upstream just fine. It doesn't require OpenShift, but their README isn't real friendly about that, or it's not obvious, at least just glancing at the README. So I just need to clarify, I guess, what they're that they won't have any concerns supporting it upstream. Well, and support upstream is always loose, right? But just making sure that that's not an issue there. I'm sure it works on standard Kubernetes though. Yeah, we just need to confirm with them if there's any concerns there.
Is there any chance to get the LSO into the Rook organization?
Like under the GitHub repo?
Yeah.
Make it part of Rook.
Right. Yeah, I don't think that I don't know, it's sort of a political question to some degree. We could make it, from Rook's perspective, I think it would be nice to have it as part of Rook, kind of a recommended local storage operator to use, just like we've got other operators in Rook. But sort of taking it over, the LSO team has been kind of shepherding it and interested in keeping ownership of it. So going that direction, I don't know. I don't think they would be excited about that proposition, but we could always bring it up for discussion.
Let me just chime in here. I mean, I think setting aside what all the politics of the different projects, I think in our dream scenario that the local storage operator that we'd like to have is one that would give us the ability to inspect the hardware inventory so we can see what the directly attached devices are. It would allow us to provision a raw device as a PV, without any partitions or LVs. It would allow us to get, and also would allow us to dynamically carve out pieces of PVs. I want 10 gigabytes here, and I want 30 gigs there, either as LVs or as partitions. If we could do all of those things, that would be, I think, a fully complete local storage operator. None of them right now do that. LSO only lets you do a raw device as a PV, but it doesn't do dynamic provisioning. Does let you inspect the hardware inventory, but again, it's not dynamic, so it's kind of frustrating. Topo LVM does all the LVMs, but it doesn't let you inspect inventory, and it doesn't let you get raw devices. And OpenEBS local lets you inspect inventory. I can't remember what else it lets you do, but I don't think it gives you raw devices either. I forget. But none of them do all of those things. So it'd be nice to have one operator that did all of them that we could maintain and recommend, and ultimately I think include in the product, because I think one of the gaps with Rook Ceph right now is that everything is always redundant. You can only provision reliable storage, and I think there are lots of users who also want non-reliable storage, because the application they're deploying either just needs scratch space and it doesn't need any that kind of durability, or because it already handles durability at another layer because it's MongoDB or Spark or some other thing that has some other existing distributed replication framework that it uses. And so I think it'd be a nice complement to Rook Ceph if there were a Rook local thing that you deploy along with it that does all the non-reliable stuff, both for upstream and for downstream. So I kind of wonder if we should just basically scope out what we want and then look at the existing projects and what they do and see whether it makes sense to try to adopt one and extend it, whatever the missing pieces are, or just build something fill that gap.
Right.
I think.
And if there's
yeah,
and if there's one that we think is closest, should we go contribute to that one and improve it?
Yeah.
or just create our own because none of them are interested in what we're trying to do or whatever.
Yeah. Yeah. Yep. And I mean, I think the putting it under the Rook umbrella is an interesting, I guess, like unity, political, whatever conversation because if memory serves, like the Rook brand or whatever was repositioned several years ago to like not just be an operator for Ceph, but to be an umbrella for lots of operators. And that was sort of the basis under which it was accepted into DNCF. But then a lot of those operators sort of disappeared. So,
Exactly.
but I
So this
think
would help with that vision.
if it had a local one, then it would be a like, it feels like it would be a feature complete operator. Like it has all of the storage things that you want. And even in the cases where you're like deploying on top of EBS, I think it'd be pretty valuable because you could, for example, deploy the Rook local one by provisioning a big EBS volume and then carving it up with LVM into all these smaller pieces. Because you can't do that with the EBS attach rates are slow and there are maximum number of attachments you can make. All the stupid annoying existing issues with EBS, for example.
Right.
It would make it pretty useful even in that regard. I don't know.
Yeah. Yeah, I totally agree. It would, I mean, it just kind of fits with the Rook vision. Hey, let's give you operators that help you complete the scenarios you need for storage. Uh, if you need redundant storage, use Ceph. If you need non-redundant or just local affinity, then use the LSO operator or whatever we call the Rook one. Yeah. So.
And then also Rook Ceph could consume Rook local, which would be nice. They would complement each other.
Exactly. Yeah, it would just come with the same solution. You don't have to go install another operator by some other means. It just come together. Right.
And it would gain a lot of upstream.
Yeah. Go ahead.
No, go ahead, please.
Yeah, just having upstream community around it too, because it doesn't exist today for LSO, for example. And also, I think it would help us get to the vision of running everything in Rook on PVs, and we could get away from the devices if we have something more integrated, potentially.
Yeah.
We don't need an external solution.
I'm a little bit nervous about LSO in this case, just because I'm not sure that I think it would need pretty significant changes in order to like tick all these boxes because or maybe not. I don't know. The way that it creates all the PVs, for example, is not what we want. Like I think it needs to be a dynamically provisioned thing where it has an inventory, and then if you have a PVC that says I want a complete device, then it would give it a whole device, and if it wants an LV, then it would go find a complete device and create LVM stuff, and then generate your LV and so on, or partition or whatever it is, right?
Exactly. If we really need the dynamic provisioning, which makes a lot of sense, then trying to adopt or change the LSO doesn't make sense, or it doesn't fit as naturally, I think. So maybe learning from LSO is what we might think about, and then just assuming we're going to go implement a new operator that really works for us end-to-end.
Sounds like a lot of.
Like, I wonder if it makes sense to talk to the LSO team about like, maybe it makes sense to write up like a requirements document. Like, this is what we want to exist. How do we get it? Talk to the LSO folks and see if that's compelling to them and whether they want to like be the CEO of that, and or also talk to the Topo LVM fellow and see if that makes sense. If that's something, because I think my guess is that there's more code that to be reviewed on the Topo LVM side, but I'm not really sure about that.
Yeah, because I think it's more of a dynamic provisioning approach, right?
Yeah, exactly. Yeah,
LVs.
More like adding the inventory component and the raw device capability, whatever, to VM.
Mm-hmm.
Calling every local.
Right. Mm.
But I mean,
Yeah.
I've long had this sense that generally speaking, Ceph is like a one-stop shop for everything you need for storage. You have object, your block, your file, like you have everything except unreliable storage. And it's easy to say that like we think that your data should be safe, but there are a lot of valid use cases where you need storage that isn't reliable, or there's no reason to pay for that because you have redundancy at another layer. And it's awkward to like do that via Ceph. Like, you can create replica one pools and provision RBs on top of them, but it's just like it doesn't. It's awkward. And you have all this complexity in the stack that like isn't really necessary when like a simple LV would do the trick. So
Exactly.
it feels like a good complement. Yep.
Replica 1 pools are also not that well tested, right? It's just an edge case.
Yeah.
Maybe
And they're
it's
hard to
tested
clean
as
up.
an edge case, but it's not tested throughout the entire code base.
Yep.
And if you do try, you have strange behaviors, or can be a pain, I assume, because if you lose one OSD, then you have to delete the whole
All the
pool,
cleanup is, exactly.
yeah.
Yeah.
Um,
It's not a good fit, basically.
yeah. Right.
And I think when you have these like two, and if it's slow, right? Like if all you need is one replica, you don't need the reliability, but you're still going through all the stuff, and you're paying all this overhead cost, but you're not actually getting any benefit from it. I think the one thing you do get is you have a single pool of storage, so you can sort of manage it similarly. So like the one thing that I guess maybe the OCS operator or whatever would still probably want to do is look at the utilization of the local storage operator and also utilization of Ceph itself. And based on that, like dynamically provision more Ceph OSDs, or maybe like deprovision OSDs and reclaim some of those raw devices as raw local storage, or vice versa. Like dealing with that balance of how much is non-redundant and how much is redundant storage be something else there's an opportunity there for OCS to do something clever.
Right. Yeah.
Anyway.
But just thinking about what's next, like you talked about a requirements doc, is that something kind of already in your head, or?
I mean, this is list of things right here. It's just four item pulled by names.
Right.
Right.
Yeah, this has definitely been eating at me for a long time, like what to do really to integrate with local storage, because all the reasons you just mentioned. So I'd like to push for this as well. Cool. Okay. Next steps. That's just what I'm trying to think in my mind. I mean, we have a community meeting for Rook in just over a half hour. I think I'll bring it up there as well as a topic for discussion. The discussions usually don't go too deep there, but I'll just mention it. Yeah, and it's something that'll take time to work through, I'm assuming.
What do we do in the meantime with the manager? What do we do in the meantime with the manager module?
Current path is fine. Like it'll have the generic storage class and PD support if they're already pre-created, and it has like some minimal framework in there so that if it sees it's an LSO storage PV, it'll query its custom CRD. We could add the similar support for OpenDBS local if we wanted to, just to like show that it's not directly tied to LSO. I think that's sufficient for now. And then when we have another local storage operator that we like better, then we'll add the sort of the deep integration support. It means that until that happens, though, we won't be able to support drive groups that like tell you to carve up an SSD into multiple pieces, because LSO won't do that. But I think that's fine. I think just having the basic support for full, complete raw devices or whatever would be sufficient. Okay. So I think
that sounds
that's
good.
basically what
Just basically
Joseph's current pull request
yeah.
does. So I think we should just like basically move forward with that. And once the sort of, I think Joseph, are you there? I think
Yeah.
he's got the pull request that does the provisioning with the basic, or does listing with the LSO support in there. I can't remember if you did OSD add with the scheme or not. And then there's OSD remove.
I have a branch with OSD creation, but I'm refactoring that at the moment because it like improper. Just as a side note, for the default, like let's say the user is not using like LSO or anything, it's just like the default storage class in PV. Basically for OSD creation, there's like no way to distinguish devices by host. So it can basically only support like all available devices. You can't really use any other drive group in that.
Well, I think if I'm not mistaken, I think the way to approach that is to have it basically the PVC can claim a specific device, right? Or is that still something that also has to add? I can't remember. Doesn't do that yet.
LSO can probably support it, but like just vanilla Kubernetes PVs in the storage classes, like I don't think there's any way of.
I thought a PVC could just specify the name of the PV object that it wanted, and you could claim a specific one.
It can specify the name of the PV, I believe, but that's it.
So if we basically pull the drive group support if we implement the drive group stuff inside Manager Rook, then it can just enumerate the available devices and then generate a PV based on the specific PV that it wants to use for that particular OSD.
I'm a little confused. So
yeah.
What? Yeah, I mean, we can talk about it later, but at the same time,
yeah. Okay. Well, in any case, I guess my general sense is that we have enough to have basic support implemented, like without external blockers. And then it feels like once we basically have that working, so Manager Rook can use LSO or pre-created PVs and have some minimal functionality, be able to create and destroy OSDs. Once that's working, then I think we should shift gears and figure out how to like make a robust local storage operator. That's sort of my thought. Or I don't know. I don't know if that's something that Joseph should invest his time in, or move on to other parts of the Rook integration. If the LSO folks want to run with it, or whoever. I don't know how we want to allocate resources, I guess, but.
Right. Yeah. That's what we'll figure out. Like, is LSO going to get on board, or Soturus, top of LVM, or are we going to do our own thing?
But either way, it seems like step one is to get the basic support in Manager Rook with using either the pre-created PVs or LSO. I think we can get all the basics working, including drive groups that like use all devices, or a drive group that has some other filters. If we do the filtering in the Manager Rook side, I think we can make that all work.
Yeah, I like that we could start with the basic approach and then expand it later with the new operator. And also being able to lead the support for the other operators. Say if you want to use LSO or or others, they would work, just not as well as the one that's fully integrated with Rook.
Right, exactly. So is one week's on PTO for the next 2 weeks? Is that what I saw? The next week?
Oh, actually,
just this week he's going to be on vacation.
Okay, but he's back next week.
Yeah.
Okay. Okay.
Yeah, he's next. back next week.
Is it on the calendar? I'm not seeing it on the storage edge.
Not on the on his. Okay. Sounds good to me. Anything else we can discuss today? Perfect. So then we are a bit early. That's awesome. Have a great week and
Okay.
see you next week. Bye.
Talk to you later. Bye.
You guys.
Bye.